Yeah. We're going to be talking about spirograms and lung capacity. So usually when we're breathing, it can be represented by a visual graph, and this can be done in a lab using a device called a spirometer, which is kind of like this cone-shaped thing that you place over your nose and mouth, and you just breathe normally, and that tracks the rate of your breathing and turns it into a visual representation. So we're going to look at like a generic example and look at the different elements that go into your breathing. So this is a spirogram, and we're going to look at each section. So we're going to start off with tidal volume, which is the most basic one. This is tidal volume, this section. Tidal volume is your passive breathing at rest. It's how you normally inhale and exhale without paying attention to it, because breathing is involuntary. It happens when you're not focusing. And then when you want to put attention to it and you're voluntarily breathing and you really focus on your inhalation, your inspiratory reserve volume is the maximum additional volume that you can inhale of air after your tidal volume. And it only goes so much because you only have so much lung space, right? For each individual, this volume is going to be different. But inspiratory reserve volume is the total amount of air that you can inhale after you've already inhaled your normal tidal volume. Then we dip a little bit because we can forcefully inhale. We can also forcefully exhale all the air from our lungs. But this goes to a certain point, and this is the expiratory reserve volume, the maximum amount of air that can be exhaled after your tidal volume exhalation. So it's this section. Because even though we put energy into thinking about exhaling all the air from our lungs, there's always going to be residual volume left. That's air that remains even after a maximum forceful expiration, because without this air, your lungs would just collapse. So expiratory reserve volume is all the air that you can exhale at will, because this is not movable. So therefore, your inspiratory capacity and your expiratory reserve volume make up your vital capacity. And your vital capacity is the total amount of movable air within your lungs, the air that you can actually control. Because other than this, the residual volume you can't touch. No matter what, you can't exhale this additional air. Then your total lung capacity is just the max volume of air that your lungs can hold at any given time. And that's made up of your inspiratory capacity plus your expiratory reserve volume plus your residual volume. That makes up your total lung capacity. So in equation form, your total lung capacity is your reserve volume plus your vital capacity. Because your vital capacity is made up of your inspiratory capacity, the amount of air that you can breathe in, total amount of air that you can breathe in, and your expiratory reserve volume, the total amount of air that you can breathe out. So again, total lung capacity is reserve volume plus vital capacity. This section plus this section. And vital capacity is made up of inspiratory capacity plus expiratory reserve volume. And that's all of your lung capacity. So now to look at some factors that affect someone's total lung capacity, because to start off with, lung volume does not equal aerobic fitness. Just because you are very aerobically fit doesn't necessarily mean that you have a lot bigger lung volume. Lung volume is to look at a biological thing, right? The bigger you are, and that's to do with size and height, is how proportional your lung size is going to be, because the bigger your lungs are, the more volume there's going to be. Second one is age. So as age increases, your lung volume will increase because your body is growing. There are some developmental changes, but it does plateau. And actually, as you get older, the dip goes down because your muscles go through atrophy and the elasticity of your lungs decrease. Therefore, it's not able to expand and deflate as easily to contain the air. Another one is gender. Males generally have bigger lungs, and therefore they have bigger lung volume. Another one is health and disease. So if you have some type of lung disease like pneumonia, your lung volume is going to go down because your health is reduced. And the last one is training. So although this statement does apply, lung volume does not equal aerobic fitness, training is useful because it allows individuals to be able to control the way that they use the volume of air within their lungs. For example, individuals who are more fit will have more muscles that can aid in exhalation and inhalation and make it more efficient and optimizable. So that is everything for spirometry and lung capacity.